Physical pain and emotional dread are the inescapable guardrails of the human experience. From the sharp sting of a cut to the heavy, sinking feeling of anxiety, these sensations define how we navigate the world. Natural selection built this alarm system for a very specific reason. Without the immediate, visceral feedback of pain or fear, we would easily push our bodies past their limits and destroy ourselves by sheer accident. But a tiny fraction of the global population walks through life completely shielded from this feedback. They do not feel a burn. They don't register a fractured bone. Physical injuries simply do not hurt. And this profound immunity extends directly into their psychological state. These same individuals live with a total absence of baseline anxiety, panic, or dread. This disconnection exists independently of a person's mindset or past experiences, functioning as a hard-coded feature of their biology. The total absence of suffering in these individuals is a biological mystery hiding deep within their cellular structure. When our most critical survival mechanism breaks this completely, it gives researchers a rare window into the body, allowing us to map out exactly how human biology constructs suffering in the first place. To understand that construction, we look past the brain and central nervous system, zooming down to the microscopic level of individual enzymes. When you sustain tissue damage, the injury site generates localized chemical warning signals. Enzymes translate this damage into a chemical code. This code travels up a continuous feedback loop along nerve pathways, connecting with a brain receptor. This triggers activity you register as an ouch. The human experience of pain relies entirely on this fragile, continuous chemical transmission functioning perfectly every single time you get hurt. In those select individuals who feel nothing, this exact transmission process is interrupted by a rare genomic anomaly known as the FAAH-OUT mutation. Inside a body with the FAAH-OUT mutation, the initial response is identical. The injury site generates warning signals, but the mutation acts as a biological dead end, intercepting the feedback loop. This creates enzymatic silence. The distress message hits a void, failing to transmit. And because the body reuses these pathways, this exact same dead-end mechanism applies to the neurological triggers responsible for generating anxiety and fear. The FAAH-OUT mutation doesn't make these people immune to physical injury or psychological danger. It simply permanently silences their body's internal reporting system. Moving from the microscopic genetic level back to the scale of human medicine, this biological silence presents a unique contradiction. For the carriers themselves, living entirely without pain or fear is actually a severe evolutionary liability. Without a functioning alarm system, they can easily lean on a hot stove or walk on a fractured ankle until it shatters. Yet for millions of people living with severe or chronic pain, safely muting that alarm system is exactly what they need. Historically, modern medicine has managed severe pain using blunt force, highly addictive treatments like opioids. This mutation serves as a biological blueprint, offering a physical roadmap for silencing pain by mimicking a specific genetic error. On the left, a traditional painkiller suppresses the entire central nervous system. On the right, replicating the FAAH-OUT mutation creates targeted enzymatic silence, stopping pain precisely at the signal site. Scientists are synthesizing compounds that mimic this targeted block, pushing them toward clinical trials. A rare genomic glitch created a life without fear for a select few. Now, by studying exactly how their alarm system broke, we have a clear blueprint to safely alleviate pain for the rest of the world.